Okay, so how can you work with these word vectors, with these word embeddings in practice? So when you work with spaCy, you can simply load existing word vectors. So you don't have to train them yourself. You can just load them as part of a language model. So like before, you import spaCy, you load the language you want to work with, like English. The main difference to before is we use the small model so far. And the small model doesn't include any word embeddings. So if you want to have the word embeddings, you have to load the large model. And as you can guess, you need a lot more memory to be able to load this model. And then you'll see that each of these tokens, if they have a word vector, you can just work with it, print it out, do calculations with it. So if you take the 3 words here, dog, cat, banana, we tokenize it just like before. And then we go through all of these tokens and compute the similarity between these 2 tokens. And what this computes is the similarity between the word embeddings, between the word vectors. And what you get, obviously, is that dog and cat and banana with itself have a similarity of 1. And in between, you have a different similarity. So you can see dog and cat using the word embeddings have an 80% similarity, but dog and banana only 24%. Still 24%. There are some dogs that look vaguely banana-like, I guess. Whereas a banana to a cat is 28%. And what else do we have? Banana to a dog, well, this is just the opposite, 24%. So bottom line is in a large model, for the words that are in the word model, you have a word vector, and you can just work with it. Later on in the next lecture, you'll see how we do more advanced NLP using deep learning models. And basically what they use as input are these word embeddings. If you want to create your own embeddings, one of the best known libraries for doing this is GenSim. So you can both use pre-trained model with GenSim, but this is also a library to use if you want to make your own word embeddings. So you have your own corpus, your own documents for a specific domain, and you want to represent it in form of these word vectors. There are also lots of visualization libraries around. So again, you can visualize cities, for example, in 2 dimensions. And then like before, you can see that cities that appear in a similar context in the news will have a similar representation in this vector space. So like Houston and Dallas, Honolulu and Reno, San Diego, San Jose, Los Angeles, San Francisco, and so on. There's also a downside, which comes back to something I mentioned in the very first lecture, namely that they can introduce a bias into your AI. Why a bias? Well, because they learn the representation from the corpus that you give it. For example, if you take the word vectors from the standard news corpus and now you compute how close is a man to a nurse and how close is a woman to a nurse, it will tell you that the distance between man and nurse is a lot bigger than between woman and nurse. So if you're using this AI model, it now has a gender bias because it assumes nurses are much more likely women than men. And yeah, in the first lecture, I mentioned that an AI that has a bias can lead to lots of problems when you apply it in a real world context, like this example of a recruiting AI that goes through CVs submitted by applicants and trying to find, for example, what is a good match of a position to a person. Now you understand why this is not a simple thing of bug fixing. You cannot just remove the bias. The bias comes from training billions of words. And it learned this implicit bias because that was in the corpus that you fed into the model. And there's no simple way to remove this bias. So in a case like this, there is not really a simple fix. And this is the reason why a system built on a technique like this had to be scrapped. In this case, it was not the news corpus. It was a corpus they used on all the existing staff. And again, if you train it on your existing staff, where most of them are male and white, then the system has this implicit bias that a new applicant will be a much better match, much closer distance than an applicant that is rarer, like Black, Asian, female, whatever applicant. So be careful with models that you use. Word vectors can encode a bias, and you have to address this in some form. There are a number of other libraries for working with word vectors. One noteworthy one is the fast text library, which comes out of Facebook. And the main difference between fast text and word2vec is that it's not trained on whole words, it's trained on character n-grams. So what fast text is doing is taking a word like whisper, and then you can split it into 2 grams and 3 grams. So you can split it into WH, WHI, HIS, ISP, and so on. So just like before, we took a sentence and we took word n-grams, but now we do it with character n-grams. And then you can do the same thing. You can train the model on these individual word n-grams. And the advantage is now that it works also on words you have never seen before. Now you can put these n-grams together into new words. And even if they did not appear in the training corpus, you can compute a word vector. It also works on words that are only partial or that are misspelled. If you think of Facebook, social network, you might have newly made up words that are not properly spelled. And by breaking it down into 2 grams, 3 grams, you can still make calculations on these word vectors. So fast text is again an open source library from Facebook Research, and you can download pre-trained models for hundreds of languages. And finally, there is a way to compute word vectors on whole documents. So there is a library called doc2vec, and the idea is that you get a single vector representing a complete document. So somewhat similar to what we did before with TF-IDF vectors of a document, but now using these word vectors. And the way it works roughly is that we have the same word vectors like before, but additionally, we have a vector that represents a paragraph in a document or even a whole document. And we're going to use this as another input for the neural network training to predict the next word. And this way you can create vectors that represent whole documents and do something like a document similarity comparison based on semantics of the document. Okay, so today I learned 2 things. The most important one are the word embeddings, these word vectors, which is first interesting in itself because now you can have an AI that has kind of analogy type reasoning. And later on in the next lectures, you'll see this is also used as the input to modern deep learning networks for natural language processing. So in this book, Natural Language Processing in Action, Chapter 5 gives you a quick introduction to neural networks, basically what we covered here. And Chapter 6 talks about word vectors, how they are calculated, and yeah, a little bit more information than what I showed you here. So please read these 2 chapters. We'll again have lab experiments on this, and I'll see you back in the next lecture. Bye-bye.